Hello everyone, my name is Ajay Meddi from Aeronautical Engineering. In this presentation, I am going to discuss about concept theory of aircraft propulsion, and my topic is axial flow compressors. Let's come to this slide. Axial flow compressor is a type of compressor in which the working fluid flows parallel to the axis of the rotation of the rotor or axially. In this compressor, the working fluid is compressed by first accelerating the fluid and then diffusion it to increase its pressure. Compressors are mechanical devices used to compress fluids. In other words, they increase the pressure of gases using various methods. The gases entering the compressor will be at low pressure, however, it will exist at very high pressure. This pressurizing property of compressors is used in filling gases in a cylinder and ties, and axial flow compressors are mostly used in gas turbines. Most of the airplane engines, gas turbines, uses the axial flow compressors due to the number of stages. They are less number of stages and they are easily mounted on a gas turbine. Easily mounted in the engine, and the efficiency of axial flow compressor is less than centrifugal compressor, but it will give some efficiency. The weight of the axial flow compressor is very low as compared to the centrifugal compressors. Centrifugal compressors are more efficient in the ground, used for anything for purposes, but for air or anything which can fly, the axial flow compressors are mostly used due to its structure and more things. Compressors are normally classified into two categories: positive displacement compressors and dynamic compressors. The former increases the pressure of a system by reducing the volume, whereas the latter achieves its objectives through the series of rotor stator arrangements. Axial flow compressors are a type of dynamic compressors. These compressors allow the fluid to attain high velocity initially, but creates a restriction in the airflow later. It will cause the gas pressure to rise. In addition to axial flow type, centrifugal compressors and mixed flow compressors form other categories of dynamic compressors. In axial flow compressor, the gas enters and exits the compressor in axial direction, and the compression process takes place in two steps. The flow is accelerated while moving through the blades or rotor. The accelerated flow is then restricted by the stator blades. It causes the kinetic energy to transform into static pressure energy. Axial flow compressors consist of rotor blades placed on the rotor and stator on the casing. The axial flow of air through these alternatively placed rotors and stators results in an increase in their final pressure. Mostly the compressors are used to rise the pressure, which is used for the combustion, and the compressors which are going to rise the pressure of a gas that will be used for cabin pressurizations in aircraft. In this diagram showing that axial flow compressors, they are set of blades, that moving blades and stationary blades. Moving blades and stationary blades. The stationary blades we call it as stator, and the compressor is run by the turbine. It is power absorbing devices. We should call it as power absorbing devices because it will absorb energy from the turbine. Working of an axial flow compressor. The basic working principle behind an axial flow compressor is that rotor imparts kinetic energy to the gas. This kinetic energy is later converted to static pressure when it is diffused through passages or when it strikes on the rotor. Sorry. For an axial flow compressor, the flow of gases is along the axis. At the start, inlet guide vanes or stator blades are present. It is to ensure that the gases strike on the rotor with the proper angle of attack, and the rotor is placed next to the stator blade. The aerofoil shape of the blade is crucial feature for this action. Axial flow compressors work in many stages. A rotor and a stator together constitute one. Generally, there can be 5 to 15 stages in an axial flow compressor. The number of stages is determined by the pressure ratio that needs to attain as well as the amount of gas. The stator and rotor blades are alternatively packed. Gases first collide on the stator or the first guide vane. It guides the gases to the rotating rotor blade that follows next. The rotor blades then increase the kinetic energy of the gases and supply it to the adjacent stator blade. The gases then fall on the stator blades when it hits on the stator. Its pressure energy increases, but at the cost of its kinetic energy. The gases with a decreased velocity will now move to the next rotor. Velocity triangle for axial flow compressor. The analysis will be carried out at the mean height of the blade, where the peripheral velocity or blade speed is u. The absolute component of velocity will be denoted by c and the relative velocity by v. The actual velocity will be denoted by ca and the tangential components will be denoted by subscript w, for example cw or vw. Alpha denotes the angle between the absolute velocity and the axial direction, and beta the corresponding angle for the relative velocity. Elementary analysis of axial compressors begins with velocity triangles. In this diagram showing that velocity triangles of axial flow compressors, the blade, you can see that it is in the shape of the airfoil. I mean, it will decide the flow. The air approaches the rotor with a velocity c1 at an angle alpha 1 from the axial direction. Combining c1 vertically with the blade speed u gives the velocity relative to the blade v1 at an angle beta from the axial direction. After passing through the rotor, which increases the absolute velocity of the air, the fluid leaves the rotor with a relative velocity v2 at an angle beta to determine the rotor blade outlet angle. Applying the steady flow energy equation to the rotor and recognizing that the process can be assumed to be adiabatic, it can be readably been seen that the power input is given by W is equal to mcp T02 to T01. Thanks for watching. Again, I will show my entire presentation. Thank you.